Hey, aerospace class. You guys last week had an assignment to make the Dragon plane. Hopefully, yours turned out pretty good. Mine's not too shabby. This week, what you're going to be doing with that plane is making some adjustments, trying to get it to fly as long as straight as possible. But I want you to do it following the procedure that I have outlined for you in the assignment. So the assignment this week you will be following is what you see on the screen here. Okay. And what you're going to be asked to do is once it's made and it's done, you're going to fly your plane. Now, keep in mind, when you fly this plane, try to find a place that is relatively large enough that it's not going to hit something, okay, which stops its flight. We want it to come to the ground naturally. And hopefully calm too. So I don't know what the best scenario for you is. If you have a nice size garage, that might work. If the plane flies real good, that might not be big enough. Do you have somewhat of an open basement? Will that work? If not, you have to go outside. The problem with going outside is you're always dealing with air currents and winds that can be changing. So that's not as desirable. But if you can do it indoors, this is much better. If you could go somewhere that's big open space, in a gymnasium type environment, better yet. Okay, so do the best, find the best environment you can. The more consistent, less variables, like the wind, as I talked about, is going to be better for you. So when you're following that document, you're just going to fly your plane as you have it built. And I'm just tossing the plane, okay, just like you kind of would a dart. So try to keep it as level as possible when you throw it. In other words, don't throw it upward, okay? Don't obviously throw it downward. I like to try multiple attempts before I make a decision on how it's flying because each time you release it, that could vary some. So if you do it multiple times and find the best distance traveled, that's what you want to do. Now, when you do fly it, it's likely not going to go perfectly straight. So in the assignment that I have here, you'll notice I use the word vector a lot. You guys know what a vector is, right? A vector creates a straight line to something. So even though your plane curves and it may have flown 10 feet, it could have actually curved around and landed right back to where it started. So what we're looking at is total displacement, where you launch from and where the plane landed. Take a straight line from the start point to the end point. That's what we're calling the vector. Okay. So you could have the farthest flying plane altogether and have the vector distance be 0 because it could just fly right around in a circle for several hundred feet and land back at your feet. And that would not be a very good desirable outcome for what we're trying to do. So we're looking at distance traveled on a vector straight away from you, okay? You can step, if you have a tape measure, you can take measurements with it, and, that's great. Or if that doesn't work, you can just kind of step it off, all right? Just as long as you're consistent on your steps, you can put down record information in steps. So um, I'm going to just launch this once for you. I know you can't see what mine did, but I'll describe it to you. It took off kind of nice and then started curving, and it curved back under the table here. I'm going to go retrieve it for you real quick. So right away, mine has a curve to it. That's okay. I would try that multiple times and not do anything different other than, try to throw it the same each time and record the information. How far is it traveling? By the way, if I did record that one and I did it in feet, it probably ended up being about 6 feet from me, even though it traveled much more than 6 feet. Okay. Then I'm going to have you guys try putting a dihedral angle in the plane. All right. So if you remember, a dihedral angle is the angle the wings are off the horizontal. All right. Right now you can see mine are pretty straight, pretty flat, no dihedral. An anhedral would come downward. Okay. Dihedral goes upward. All right. Right now I've got, I don't know, maybe 10 degrees, 15 degrees off the horizontal for a dihedral. Okay. And try flying your plane multiple times with a dihedral. Does it improve? Okay. Once again, I want you trying it at least 5 times, multiple times, and then record the greatest distance traveled in this spot, okay, with a dihedral. Then we move into rudder control. So what are you going to do for rudder control? So don't make all these changes at one time. Do them incrementally. Let's see how your plane performs. Does it get better? Does it get worse? You know, if it's getting worse, you might try a little less dihedral. If it's totally worse, you might try no dihedral, right? But rudder control. So because of the way the plane is, and let me just point out one other thing that's kind of important. This plane was engineered to fly pretty good. Planes, as you know, we've already talked about it, will fly fairly level if they're balanced and all the control surfaces are trimmed to neutral. Okay. So what do we mean by the plane being balanced? Well, we already did this last week, right? You know that the balancing point on most planes should be about a third of the way from the leading edge towards the trailing edge. About a third of the distance should be about the balancing point of the plane. If I checked this one, and if I held my fingers like right here, okay, notice, going from the leading edge back, I'm only about a quarter of the distance. I'm going to do that for you here. I'm going to put my fingers here, and release, and try to do that for you. And if I do that, the plane just tilts backwards, okay? If I came to the halfway point, right? So if I came about halfway here, from the leading edge to the trailing edge, about the halfway point, notice that the plane is now, not about the halfway point there, is a little bit front heavy on this, okay? So once again, I'm at the halfway point and it wants to lean forward. But if I come to in between that, right about here is a third of the way, and I just balance my plane, it's pretty level with the ground, okay? So in other words, that balancing point kind of holds true to what we talked about with your assignment last week, that center of gravity should be about a third of the way on the planes. And these are flat wings, but if they were cambered, like the planes that you guys designed and the airfoils that we created, that maximum camber is notice about a third of the way as well on most planes. And that's where your maximum lift should come. That's where the center of gravity for the balance should be. Okay. So with that said, yours should be good with that if you designed it. And I shouldn't say designed it, but if you built it the way the instructions last week told you to make it, you should be fairly balanced. So now we can control things through rudder control. Because of the way this empennage is relatively small, and most of the lift and control comes from the wings itself. So I am going to put a slice right with a pair of scissors. So you're going to need some scissors, and put a little slice, not real big. Notice I only went in maybe went a little further than I wanted to, about a half an inch or so. And I'm going to, I went about 3/4, but I should only be about a half an inch. But by doing that, you get the ability to now bend these outward, okay? My plane, by the way, was curving to my left, okay? So I already know, and you guys should know, what you should do to control that. If I put it's like two rudders here, right? But if I put those rudders to the right, that should bring the nose of the plane back to the right. And I should be able to fly that and see if actually that was pretty good. That actually went now fairly straight and had a little curve to the right. And by the way, that actually went much further, and I threw it actually quite soft, okay? So now you've got some rudder control to play with on that, and do the same thing we did before. After making adjustments to the rudder control and trimming, that the process, what I mean by trimming is not actually the cutting, which you would think was trimming, right? Trimming is a process of adjusting the control surfaces on a real plane. That's what they call it. They got a trim tab, okay, so that they can make fine adjustments to the rudder and the elevators to make sure it flies level. So your adjustments might be multiple ones, but when you get it flying fairly straight, wherever the rudder positions end up being, throw it 5 times as consistently as possible, measure the greatest distance, record that. So all you're doing in all these is recording a distance. Could be footsteps, it could be actual feet that you're using on a tape measure, okay? The next one, going down to number 4, gets into elevator control, okay? And you're going to do the same thing. You're going to put in elevator control, And now you're going to start trimming the plane and trying to make adjustments to get the fly as level as possible. So as you know already, elevators are going to cause what we call lift on the plane, right? The rudder is what we call yaw movement, okay? So what I would do is I would come to the back of the plane here and cut, and I'm going to come in just a little ways here, and I'm going to cut, and similar to what you guys did on your designs for your plane on Onshape, right? You had to have some elevator control, and if you guys were in the classroom and building it, you would have them. So on this plane, you're going to put them in, and I could take these now and I can move them up a little bit. You want to keep them, and same with the rudder, you want to keep it relatively consistent. You wouldn't want one really high and one really low in most cases. But as you can probably see there, I put some elevator up on it. If my plane seems to want to pitch up really high, which could happen if it's a little bit unbalanced, I could use my elevators down to bring it down a little bit. All right. If it seems to dive right away, okay, I could bring my elevators up, okay, which should be able to, pitch the plane up. So once again, I'm going to throw my plane and see. Actually, that actually went really well. So you guys can't see it obviously, but that ended up going down near my front door of my room, and I'm sitting in the neighborhood of 15 feet away from that. So it does make a big difference on adjusting those. So you're going to play around and make those adjustments, get it to fly as far as possible after adding the elevator. And then finally, the last one here. Answer this question. Did those changes make an improvement to your plane? And if so, what was the greatest distance traveled? Okay. So wish you guys, were able to be in the classroom and build your plane. But we're going to have some additional activities. This is just, kind of a 2-week thing with this paper plane, but you do get to control the behavior of it like you would if you were building the planes in the classroom that the other students are. And the next few weeks, we'll have some other activities for you to do to compensate for the, hands-on activities that you'll be missing in the classroom. Okay. So as always, make sure you do the at-home assignment in that folder. Have a great week.